We're all set now, broadcasting, and we are going to spend the rest of today continuing to talk about adding vector data to our maps. And for the most part, the way that this is currently done is through using GeoJSON. And we're gonna continue to talk about that for a few more examples, and then we'll also talk about how to do it using ArcGIS. Now, in the background, when we make a request to an ArcGIS server, and it adds when we do this through Leaflet, it's actually still using GeoJSON. It's making the request to ArcGIS. It's making the request. We'll show this in a second, but it's making the request to the server. The server is creating it in the ESRI JSON format, and then it's converting it to GeoJSON to display it in Leaflet. So we'll follow that through here when we get to it. First, let's talk about requesting data from an outside server and getting JSON from that server. So I think I actually closed it already. So what I'm going to do is I'm going to work through. I'm going to work from this example called It's called geojson.html. It's that one. So if you download that one, that's the one I'm going to work through. I already have it, so I don't need to download it. What I've done is I've just built off of that Montana example. So it's not it's not anything additional. In fact, none of the references that we had earlier I've taken out. Although I could have taken out this reference right here because we no longer have the slider. There's no longer any what we call jQuery UI associated with this page. So we still have this function that gets fired when the page loads. Okay, so all that's the same. All this is the same. This is the code that we wrote on Tuesday, or the code that we talked about on Tuesday. It basically loads up that Wyoming boundary from a different file, and it takes that Wyoming boundary and adds a pop-up. And then we also added, remember I went in there and I just fudged that other little triangle shape that's down here. The other features you see on here we'll talk about in a second. So that's, ignore the circles, the orange circles. That's where we were on Tuesday. And that's what this code does. All right, the next set of code that I want to talk about is P doesn't need to be on there. If I take this URL here, I press paste, you'll see that this URL is to somebody who's placed JSON, GeoJSON, in fact, on their website. And it's not just any someone, it's the US government. So anybody know what USGS stands for? Probably all. Yeah, the US Geological Survey. The US Geological Survey has a server out there that's actually updated all the time. And so this data that you see here will change. It'll change. So this is actually for the week. Let me go to this. I think it is, just have to delete this far. Okay, yeah. So, yeah. So here's the GeoJSON. I think I hit the detail feed. Is that what I hit? No, I hit the summary. Yeah, okay. So I hit the summary. So I just typed in GeoJSON feeds, and this is one of the ones I got. Okay, so here's the GeoJSON feeds, and they have all these bullet points that show you the earthquakes that have happened in this updated every 5 minutes. So these are the significant earthquakes that have happened in the past hour. So I hit that. If you'll notice, how many features are there in this GeoJSON? There's not any. So there hasn't been any significant earthquakes in the last hour. All right. See it says features and it's just empty. If we go to all of the earthquakes that have been bigger than 1 on the Richter scale in the past hour, we get a few. So now features is full. I can't tell exactly how many there are here, but it looks like there's about 3 or 4 features. In fact, I could search for the word feature. It looks like there's 1, 2, 3, 4. There's been 4 earthquakes that are bigger than 1 in the last hour. So that's the way you would read something like this. Here's all the earthquakes that have occurred over the last hour. It looks like it looks the same. So the one that I copied was this past 7 days, and I hit M 2.5 or greater. I hit that button. So see all this, all of these earthquakes have happened over the last week in the United States. So what if I wanted to put them on my website? I wanted to make a map of those earthquakes, because a map would obviously be a lot easier to read than what we just saw, right? I mean, if somebody not seen JSON before, they have no idea what that was referring to. All right. Now I could click M2.5, right, and I could copy all of this data. Copy, and I could paste that data into a new thing. So now I have all the earthquakes that have happened in the last week. And that might be a good solution, an adequate solution. Well, what would be one of the disadvantages? Like, let's say I hook my page up to this copied version of the earthquakes that have happened in the last week. What would be some of the disadvantages of doing that? Yeah, I couldn't access it from a different machine unless I also copied this other file onto there, right? To that other machine. How about next week? Next week, is this going to be the earthquakes that happened over the last week? No, next week, this will be the earthquakes that happened 2 weeks ago. In 3 weeks, it'll be the earthquakes that happened 4 weeks. So it might be that for a particular application, we might be interested in kind of archiving and storing and always showing those earthquakes. You know, maybe we knew that there was some interesting thing about the earthquakes that week, and so we want to make a map of the earthquakes that happened that week. This would be a perfectly acceptable way to do that. But it's much more likely that we want to make a map that was showing the real-time earthquakes. In order to do that, we need to add a reference in our code to the service that's being updated. So I'm not going to save that. This is a service. What do I mean by it's a service? This is a service that's serving up GeoJSON. What does that mean, that it's a service? Is this a static file that sits on their server that every time there's an earthquake, some lackey at USGS runs over and types it into the GeoJSON? Is that what you suppose happens? How does this occur in general terms? What's going on? Yeah, there's a program that writes this GeoJSON and it's drawing off a database. Now, whether somebody manually enters that database, the information into that database or not, is is unknown, but I suppose that that's also automated, that there's actually machines hooked up to seismographs or seismometers that are measuring their earthquake shaking, and that information gets put into the database automatically as well. And so there's one program that's doing that, but there's a service, in other words, there's a program running that every time you type in this URL, what it does is it receives that request and it goes to the database and says, okay, give me all the earthquakes that happened in the last week, because that's the URL that means give me all the earthquakes that happened in the last week. It gives it all the earthquakes, and then the service handles turning that text into JSON. Okay? Now, our Geo server does the same thing. If we went to layer preview here, and we went to our neighborhoods, and we did the drop down for GeoJSON, GeoServer has the ability to convert. So these are the, I think we showed this, right? GeoJSON has the ability to do that. I don't think that the USGS is running GeoServer. They've got some other server. They could have written it themselves too. They've got some service though that's handling requests and responding back with GeoJSON. And it doesn't really matter what software they're using. It just matters that their GeoJSON is GeoJSON, because if it's GeoJSON, Leaflet and other web mapping APIs know how to handle it. There's a specification for how GeoJSON needs to be written. So that's what's occurring. Okay, and you'll notice that not in our example, but in this example, the GeoJSON is taking these features and it's giving them to us in latitude and longitude. In fact, you'll notice the coordinates are right there. So that's a latitude, a longitude. What's that third number, do you suppose? Anybody got a guess? Associated with the coordinates. There's some music going on down the coast, right? Hey, can y'all hear me on the coast? Are y'all down there? I thought I heard somebody. Did anybody walk in or out? Michael, are you down there? Hello? Got some pop music. All right. I'm going to turn the volume down if I see anybody walk in. What just happened here? Oh, did I hit the button by accident? All right, they can still hear us probably, but now we can't hear their music. That was weird that it just started playing, right? If nobody's down there. Ah. Okay, so the third number. The third number is, you might think it might be a magnitude, it's not. So that would be in the attributes anyway. This third number is an elevation, and you'd have no way of knowing that, except for it does allow in the specs for coordinates to have 3 dimensions. So this is X, Y, and Z in this case. It's the elevation. So here, where's another one? Right here, X, Y, Z. And then there is another place in here that, because it reports the elevation twice. Let's see, 23. I guess it doesn't report it twice, but it is the elevation. The magnitude is in the attributes. There's the magnitude. There's a few properties. One of them is the magnitude, 3.9. All right. So that's an attribute. Place is an attribute, where it's got a name. associated with it. It's got a time associated with it, things like that. Okay, so if we want to get this data, then we have to use, well, the easiest way to get it is to use, and I told you that we'd be doing this on Tuesday. The easiest way is to use a jQuery library for going out, or sorry, a jQuery function from the jQuery library that's designed to go out and get JSON data, okay? And it's a function called getJSON. So this function, it's just got the jQuery $.getJSON. And this function, what it does is it takes a URL, so I've given it the URL to the JSON, and the other thing that it takes is a function to execute once it's done getting the JSON. What does that mean? So sometimes in the web world, you have to think about things as requests and responses. So when we execute a function, this is executing a function right here. This I should show it up here so that this part right here is executing a function. But nothing actually gets done until the response comes back from the server. So this part is saying, okay, run this function once you've gotten the data, and it's going to put the response. And a way to generalize this would be to write response data right here. So this is saying, okay, there's going to be some JSON at this URL, and once you get it, run this function, and I'm going to call the result response data. I called it Quakes in my code because that response data represented Quakes. Does that make sense as to why I do that? So let's just take it down to this point. And notice I have a console.log Quakes. I'm going to refresh this page after I add the developer. Okay, so I'm going to refresh the page. What's already there, actually, but I refreshed it anyway. So you see that object. That object is that console log. The reason why I know is because it says it's 68, line number 68, and in fact, it's line number 68. So those are the Quakes that came back. Okay. So these are the Quakes. These are these Quakes. And it says that there are 246 elements that came back, 246 of those Quakes that came back. And I can go look at the individual Quakes here. The very first one has an ID of AK117539. Well, the very first one on here should have an ID similar. Yeah, I can just search for it. They're not necessarily guaranteed to be in the same order, but is this the same URL, 2.5 a week? Anyway, that record is in there somewhere. So these are all the features that came back. These are all the earthquakes. Okay. Now, if we go read the leaflet, I'm sorry, I should move over a bit there. If we read the leaflet help, we can see how to symbolize a bunch of GeoJSON. We've actually already done that. We did the same thing right here. L.GeoJSON. We gave it the data. That was the data from Montana and things. So here, we're going to do the same thing. We're going to say L.GeoJSON, and we're going to give it the Quakes, because it's just the data in this case. Okay? Now, I'm going to open up the help for the leaflet. I'll just write leaflet JSON or GeoJSON. And then you'll see this statement right here. Whoops. We've got this statement right here that says points are handled differently than polylines and polygons. Okay. By default, simple markers are drawn. So if you don't want simple markers drawn, then you have to provide another symbol, whether that be a point symbol that is that's just a dot on the map, or like let's say you wanted to put an image, like you had your own little point symbol that you created that was a PNG. Remember when we did the dancing banana? You could make dancing bananas for all the points, okay? But you wouldn't use a circle marker for that. You would use the whichever one we used. You can go back and look at the code for the dancing banana, but we didn't use the circle marker. But here I've said a circle marker. So we can go in, and I've made my own circle marker right here, and that's what you see on the map. I actually didn't make this circle marker. I copied this right from Leaflet. So this is the circle marker that it used, and I copied it over. Let's experiment with it. Like we can make it smaller. Let's only make it 5. Now when I refresh this, I get smaller dots. Okay. If I have my dots be 30, I'll get larger dots. And likewise, I could color them different colors. Okay. All right. Now what I do want to show is how can we symbolize our dots more effectively? These are earthquakes. Are all earthquakes equal? No. Some earthquakes we want to symbolize them differently because they're bigger things. Okay? So we can put an if statement in here in this line of code, because what's happening here is that it's going through every feature. That's what this word means here. So it's going through each point, it's converting it to a layer, and it's taking that feature value and it's returning it to us. And all I'm doing right now is binding a pop-up that says earthquake happened here. It's kind of boring. But let's say I wanted to make it so that the feature is different. The symbol is different depending on the size of the earthquake. So what I could do, and there's actually more than one way to do this, but this is the way I was thinking of doing it, is create 3 marker symbols and call this small, medium, large. Maybe I should spell out medium. Okay. And so for my radiuses, for my small, maybe I'll go with 5. And with my medium, I'll go with 8. And with my large, I'll go with 15. Okay. Maybe I'll go with 9 here. And so I've got a small, medium, and a large one. And maybe what I'll do are red, green, and blue. So I'll go like this, FF, and then go like this. So I don't expect you to know off the top of your head what that did, but basically, if you mix red, green, and blue, and you mix FF, and FF is the highest, FF is the 256, 0, 0 would be 0. So we're saying 256 red, 256 blue, no green. I mean, sorry, 256 red, 256 green, no blue. That turns into yellow. So we're going to make small yellow dots for the small earthquakes, medium-sized orange dots for the larger earthquakes, and for the largest earthquakes, we're going to make them red. So we're changing the color and the scale. In order to do this, we have to put an if statement in here. So we're going to say if feature dot, what should we do here? Go back to our JSON. How do we get the attributes? What's the word for attributes in GeoJSON? It's not attributes. We talked about it on Monday a bit. Starts with a P. Yep. So we say feature.properties.mag is greater than, I don't know what we want to make the cutoff. Now we're only doing 2.5 and larger. So maybe we'll make the cutoff 3. If it's greater than 3, then we'll do the mediums. Then we'll say return L dot circle marker symbol, and we'll say medium like that. And then we'll say else. We'll close that and say else if it's basically if it's less than that, we're going to do small. Did I end up spelling medium out? I think I did. All right. So we'll refresh this real quick. And so far I've only done small and medium, but you can see now we have a little bit richer map. It's got the smaller earthquakes are small dots, the larger earthquakes are larger dots. The cutoff was a magnitude of 3 or more. We could get really fancy and even change the size of the dot to exactly what the size of the earthquake was. Okay. Back in cartography, we would call that the difference between a proportional point symbol and a graduated point symbol. Okay. Right now we're doing graduated point symbols. All right, so let's add the large one in there. Okay, actually, the way that we would do that is add another else statement down here. Else if, and then this. So if properties have a magnitude greater than 3, then do this. Let's make the other cutoff 4, or yeah, 4. Maybe 4.5. I don't know what's going to look the best. And we have to close this one up, and we have to copy this guy over. And put large. I don't even know if there's any earthquakes that have been over 4.5 in the last week. So it may not do anything different. Oh, looks like there has been one off the coast of Canada. Although that's not in the United States, I guess the USGS measurement goes out that far. Well, it's probably pretty close to the edge of Alaska. Oh, we got some more in Alaska. Cool. That's pretty neat. Oh, maybe this isn't just the United States. I thought it was. Looks like it's worldwide. So there's a whole lot of earthquakes that have been happening over here that are larger than 4.5 over the last week. So one thing that's cool about this map is that it would be different every time you went to the map. It'd be slightly different because it's always looking at the last 7 days because USGS is always updating their stuff. Okay? So remember when we utilized the NOAA weather WMS service? Same thing applies, except for this is features, okay, and the other one was a WMS. The difference being this is drawing these dots the way we want them to look. With the NOAA weather stuff, remember with the radar map, we didn't have any control over the way that it looked. We just asked the WMS to draw itself, and it puts itself on the map. We don't have any way that's base map. We don't have any control over the way the base map draws itself. It would take too long to have all that data and be able to symbolize all the data that's contained in that base map. But in this case, we've got 256 different dots that are streaming over the internet, and they're not even dots yet. They're just GeoJSON, and we're symbolizing them the way that we want to on the front end of the map. And you can do a few more things, like let's say instead of large earthquake happened here, we could also say something like feature dot properties. I forgot what that, go back and look in here. Feature dot properties dot place. So let's say that we wanted the description to actually tell us what's going on there. So now we refresh the page and it tells us a description of the place. So that would be much more useful to the user. Enterprise. I believe I drove by there this summer. I'm driving through southern Utah. A little earthquake in the middle of Texas. That's kind of interesting. So those are the earthquakes, and that's how we can modify the data that's contained in those earthquake data. Well, not modify, but symbolize them according to the way we want them symbolized. The next time we meet, I'll introduce a library that will actually allow us to do some cool things to manipulate the points. So let's say we wanted to find out all the area that was within a certain distance of all the points. We wanted to buffer the points. Well, traditionally, that's something you have to do in a GIS system. But you can actually do that on the browser as well. But it would require a lot of code, but there's people that have written that code already for us. Okay, so that's GeoJSON. Anything else? Anybody else want something changed? I can make the opacity less. By the way, it looks like I was last week when I was trying to figure out how to make the opacity. It looks like there's some examples there. It'd be pretty easy. So I just made the opacity for the smaller earthquakes more, or I made it more transparent so that they wouldn't appear as big on the map. We could remove, I think this will remove the, no, that just made them default. I'm pretty sure that's the line weight. Yep. Okay, so that's the line weight right there. If I don't want to put circles around the dots, I want to maybe if I make them smaller, it wouldn't be as obtrusive. Anyway, you can play around with symbols all you want, but that's one of the nice things about using vector data. One of the nice things is that it allows you to show them. Services, you couldn't do that. And then the other cool thing, very responsive when you go to click on it. Okay, if this was a map service and you clicked, it would take an extra well, if the server was slow, it would take a long time, but it would take some time to get the request back every time you clicked. But if it's on the server already, it's very responsive, highly responsive. All right. So let's look at the second example. The second example is for oyster sites. Basically, I took some data off of that coastal resilience site that I mentioned before. I could have taken it off of our local machine, but I know that people on the coast have problems accessing that machine. But you all could use any of the data that you've published that's vector data. This won't work for raster data. So in fact, since there's nobody on the coast, maybe I'll also show that real quick. But so what I did was I went to the help for Leaflet. So this is called a feature layer. So the ESRI extension for Leaflet allows you to load a feature layer. And this will work for any map service that you have that contains a feature layer. So for example, let's look at our data, which is 10, then it's just ArcGIS/ArcGIS/REST. Okay, so here's our data. Matt's not here today. We'll click on his folder. He's got this Summerall test. And in a Summerall test, he has a layer called S towns. I don't know if that's point layer or not. Yeah, it's a point layer. Okay, so that's a point layer. And that layer will work because it's a point layer. This layer right here, Jones County DEM, won't work because it's a raster layer. Okay. But S-towns will work. So the URL that you see right there is the only URL you need to be able to put it into Leaflet. That's the URL you need, all the way out to the 0. So with a feature layer, you're adding data from an individual layer, not from an entire map service. So that /0 on the end, the /0 right here, means it's the very first layer in this data set. So here is the second layer in this data set. And here is the third layer. They're all vector layers, so we could add any of them. I'll start with the towns layer though. So if I copy this URL, Control-C, and I paste it into my web page, now what I can do is I can add this layer by copying the rest. I could say, okay, here's a new layer. I'm going to call this points or town is equal to l.esri.feature layer. But I want to copy in this URL that I just copied from the REST services directory. So I copy that. Okay, I have that URL. And for now, I'm just going to delete everything else beyond each feature. And it'll just symbolize it using some default symbology. At least I'm pretty sure that's what I'll do. Okay, so let's see if it pulls it up. So I'm going to refresh, and it did. So by default, remember what it said that it would do is to use those points. So these are the towns in, I believe Matt used, yeah, he did. He used Jones County here. So when I click on these towns, I don't get anything because I haven't bound a pop-up. I didn't use the bind pop-up function. But these are all the towns from his data layer. Now, if I want to symbolize those towns using some other symbology, I can do that. But I have to write in the symbology just like here. So I'd have to have this function point to layer in my function. I have to have a comma too after. Oh, there's already a comma. By the way, you see these dangly commas like this? There's a comma already right here. But there's nothing after the comma until you get to the next squiggly bracket. Chrome is okay with that. Firefox is okay with that, but Internet Explorer isn't okay with that. It would fail. It's a browser difference that you sometimes, so that's not like it's going to be on any test or anything. But so there's already a comma there, and I need to put in the point to layer function right there. And this is where I could add the symbology that I wanted to add. So I could put something like this. And this is just going to be the small earthquake symbology. Actually, I don't want to do this though. For now, it's just going to say town. So refresh this. Oh, small is not defined. That's because that's in the whole different function. So I need to add my own little symbol. I need to make my own little marker symbol. Or I think if I just say radius 5. I think let's see if there's some default. Oops, I messed up. Radius 5. Yeah, so by default it makes them blue. So if I wanted to change the color, so this is the default circle marker symbol that shows up. And I've got all those guys. Okay, I could add other, things to my object there. That's the symbol. But right now I just have radius 5. So I'm making 5 pixel circles. And right now, when a user clicks on any of those, it just says town. What if we wanted them to actually report the name of the town? How do we do that? Do we even know what it looks like? Well, we can get that information from right here, right? So this is the point. If you hit this query button, these are the points. If you hit this query button and you just say get, you have to actually enter a query here. Okay, object IDs. It's going to return all of them by default. So let's see what's the name of the field. It's FID. So the name of the field is FID. Let's say I want to get FID is greater than -1. If I put that query in there, how many am I going to get? Is there ever any FID greater? That's all the FIDs. See that? Okay, what's the attribute that contains the name? Maybe I shouldn't have even asked that question, right? But what's the attribute that contains a name? It's called name, right? So I know that it's going to be, for bind pop-up, I'm going to say feature dot properties dot what? Name, and it's got to be capitalized. I'm pretty sure that it'll care. So now if I refresh this, I zoom in, I can click on one of these guys, and it tells me the name of that town. See that? I don't know for sure if those are the right names, but hopefully they are. It looks like these are just towns because there's no dot for Laurel. Maybe they consider that a city in a different class. But anyway, that's the town points. Okay, so that's one example there. And we worked through that example. The other example I had is the oyster sites. So here, if we refresh these, you wouldn't know where they were by default, but the oyster sites are down here. Oyster sites, got 3 oyster sites. Right now I have, so that when you click on them, it says oyster restoration happening, okay? So those are the 3 oyster sites. And what if I wanted to change the color of the oyster sites? How would I do that? That gets changed right in here. The code would go right in here. I would have to give it a different symbol. Now we've been talking about circle symbols here, but I'd have to go back to leaflet and find out if there was a symbol for polygons. Let's go to docs. We've got vector layers. We've got circle markers. We've got polygons right here. Let's see if a way to symbolize those guys. Color, yep, okay. Path. Path is this, so that's what we would want to do right there, is to set the path value, okay? So it looks like it's got a fill color, it's got a fill opacity, it's got a fill rule that we could change. It's got a stroke width that we could change. We could change all of this information that we've done, and we've actually done some of that before. Okay, we did that with our circle. We made it a different color. It's really not any different here. We're just doing that on the features. If we wanted to change the layer pop-up here, we could do that same way we did the other one, feature.properties. We have to find some property to attach it to. One thing that we could do is unclick this. This is another way to find out what your features have in them. We could write console.log, and then we could say feature.properties. And now, when we run this, we're going to get a list of all 3 of the features, and we can see that there is a attribute called name, but this time it's lowercase. So we just type in .name here, and we can refresh this. And now, when we click on these guys, it tells us the name of the oyster reef. Very quick and responsive. There are methods inside of Leaflet for zooming to a particular feature, which we've already demonstrated. We could zoom to all of the features. So instead of having your map zoom to a particular feature, you could have it zoom to all 3 of the features that you have loaded. That sort of thing. So you should be getting some ideas for perhaps if you want to include vector layers in your final project. You should be getting some ideas of things that you could do. Now, you may still be thinking, okay, well, you showed this example or that example, but I wanted to do something slightly different, or I wanted to respond to something. Okay. So those types of questions, you can look on the Leaflet documentation. But if you're having trouble, then go ahead and ask a question. Say, hey, this is what I want to have happen, and then we could show that as an example in class, or I could just show it to you in an example personally. But we could do things like, we've got a time layer. Let's say we have a time layer for the earthquakes. We could put a slider bar up there that would slide through the week and show us where the earthquakes had happened over the week by setting some of the attributes, by setting the properties equal to, the transparency, the opacity to 0 for those other ones. We could do, there's really all sorts of things. So if you have in your mind something that you wanted to do, let me know. All right, let's see. I think that's as far as I wanted to get it today. I have an assignment listed here. The assignment is to create a map where you add your own vector data to it. It can be GeoJSON data. It doesn't have to be a service like the earthquake one. So you can cut and paste it and do it like we did the other one. Or you can try to use the GeoJSON one so that it's updated a lot. Or it could be ArcGIS. Now in the background, ArcGIS is really creating GeoJSON. So once it's done doing what it does, in fact, I can prove that this on each feature is returning GeoJSON. We saw it when we put it in the console window. The point to layer is also returning GeoJSON. So although it's making a request to an ArcGIS server, it's getting that data and it's turning into GeoJSON for you. So using GeoJSON, but I did write GeoJSON or ArcGIS. And you could go into ArcGIS online and find somebody's server that they had used. You're welcome to use Coastal Resilience. You just have to add a different layer than the layer that I added. Or actually, nobody's down there on the coast yet, right? But even on the coast, they didn't have trouble accessing the ArcGIS server. So you could use data that you published on the ArcGIS server, and that would be great. And that would be your own data. You could do counties, you could do whatever kind of data you want. You just have to make a map that looks like this. Where did I put it? Did I close it? Oh no, it's in my other one. You have to make a map that looks like this, and that has data that you symbolized. All right. Now, did I cover why I use incognito sometimes? No? Okay. So this little guy with the shades on, with the cap that looks like when I was a kid, they had this game called Where in the World is Carmen Sandiego or something? A long time ago. There's always like spies going on. There are little characters that look like that sometimes. Anyway, I don't know why I said that, but this little guy means that it's in incognito mode. And some people might use that for going to a website where they wanted to hide their browser history, because it doesn't record your browser history. It doesn't put anything in the cache. Doesn't mean people can't find out that you went there, but it does mean that it doesn't save information on your local computer, okay? The reason why developers love using incognito mode is because sometimes when you make a change on your website, the browser doesn't go back and get the right information from the server. It stores, your browser actually stores some information. So sometimes if you change a picture, but you didn't change the name of the picture, you just changed the picture on the internet, it might not go back there and get the new picture, okay? Same thing with an external file, like a JSON file. So we haven't really needed this yet, but I did it today just because sometimes when you make little changes in your JSON file, but you don't rename them, it's sticky and it won't re-download that file. So it won't show the change. So sometimes, and unless if you ever get to a position where you're like, hey, I'm making changes, but they aren't showing up, try opening the file in the incognito mode, and it will always re-request everything. Every time you press refresh, it'll re-request all the data because it doesn't have the ability. In this mode, it doesn't have the ability to cache anything. And the reason why it caches things is for speed. So like if you went to www.usm.edu and there's no reason why it needs to grab all the colors all over again. As long as the name of that file hasn't changed, it won't re-grab all those. Eventually, it'll time out and it will re-grab them all. But it'll take a few days or weeks depending on what the default settings for your browser are. So sometimes when I'm writing JavaScript code, I like to use incognito mode. All right. So we've got a lot of hodgepodge of different data on there, and I'm going to go and upload the most current version of this. So I'll say edit, and I'll upload Actually, I should save it as something else. So that's the file I started with, and I'll call this GeoJSON end of class, and then I'll find this in the class open. Oh, another thing I should do is save the lecture. So I'll just end this.